Welcome back, guys. Today we're doing compound inequalities lesson number 2. So remember last lesson we talked about the first type of compound inequalities. Those were the and inequalities. So today we're going to do the second type. And remember that compound inequality, it sounds really fancy, but it's just two inequalities that are joined together. So today the two inequalities are going to be joined by the word or instead of the word and. So for example, if I want to find a number that's greater than 10 or it's less than 3. So there's two inequalities there. We put the word or in between them. So let's kind of write the two inequalities to start. So the first one, a number greater than 10. So I could say x is greater than 10. A number less than 3 would be x is less than 3. And if I put them together, it would look something like this. I'd write it exactly like it looked, and I have to use the word or in between. So remember that last time with the and inequalities, I could do that like between notation where I didn't have to actually use the word and. That special way of writing it doesn't exist with or inequalities. Okay, so there's no special way to write these. You must have the word or in your answer with this type of compound inequality. So like look down here at the examples. You're going to have the word or used in between the two things. So for that reason alone, excuse me, I'm going to make a note. It makes this kind of compound inequality very obvious. So it makes this kind obvious. You know it's a or compound inequality because they're going to use the word or. Okay, so don't make that harder than it needs to be. Now, a solution, so like a number that makes this or compound inequality true, is a number, it makes either part of your inequality true. So it can either be a number bigger than 10, or it can be a number that's smaller than 3. Okay, so there's unlimited options, infinite answers. So also think about it too, if I put the word and in between here, there is no number, think about this, there's no number that's bigger than 10 and smaller than 3. It doesn't exist. It can't be bigger than 10 and smaller than 3. So if the word and was in between these two inequalities, there would be no solution. But since it's the word or, as long as my answer satisfies one inequality or the other, I'm good. Okay, so there's infinite number of solutions here. So to show the solutions, as always with inequalities, we're going to graph them. Because there's unlimited answers, I want to point out where they are. So here's what I'm going to graph. The smaller number always goes on the left on the number line. So I could put other numbers on. I don't have to. So 2's over there, 11's over there. You get the idea. I really just concentrate above 3 and 10 because those are the two numbers that I'm looking at as my like boundary numbers. So let's do this one first. I want numbers that are greater than 10. I don't want to include 10. There's not the or equal to. So bigger than 10 would be 11 and on. So I'd shade to the right. And then I want numbers that are smaller than 3. So same thing. Don't include 3. And I want 2 going towards the left. All the numbers smaller than 3. So if it's one of these numbers or one of these numbers, it's going to satisfy this compound inequality. So infinite number of solutions here. So essentially, I kind of just graphed those two inequalities on the exact same graph, and there we go. There's all my answers. So that's graphing. Now, solving is going to be like the big part of this. Okay, we did that last time. It's the same idea here. I'm going to solve it, and then I'm going to graph it to show where all the solutions are. Now, to solve these, you guys, you simply just solve each inequality because it's going to be two different inequalities. So it's going to be this first one and then this second one. So it's essentially just two different problems. You solve both of them, and then you take your two answers and you put the word or in between. So that's how you're going to like combine your solutions. So watch, I'm going to solve this first inequality first, and this should be a breeze. I mean, it's just a two-step inequality, so I'm going to subtract 3. And that's going to give me 4x is less than negative 8. and then I'm going to divide by 4, and I've got x is less than negative 2. Okay, so that's the first part here. Now I'm going to come over here, and I'm going to solve this inequality. So I'm going to subtract 7, and then divide by negative 2. Keep in mind, anytime you're solving, you have to think about if you need to flip the sign. So right here is that exact place that needs to happen. I divided both sides by negative 2 when I was solving. So no longer is this a less than, it's a greater than 3. Okay, so I'm going to bring that down. So I really just had two different problems, and then I just put the word or in between. So any number that satisfies one of these inequalities or the other is going to be a solution to this compound inequality. So any number smaller than negative 2 or bigger than 3. Okay, so if I wanted to show that, I graph it. Smaller numbers go on the left. I don't necessarily care about you filling in a bunch of other numbers on the number line. You can if you want to. So like 0 would obviously be in between. But as long as you're understanding the smaller's on the left, bigger's on the right, and you can graph this correctly, you're good. So numbers smaller than negative 2 would be open circle above negative 2, shade to the left. Numbers bigger than 3, open circle above 3, shade to the right. Okay, so that would be all of the solutions there represented on the number line. All right, on the back, so we got 4 examples here. I want you guys to do number 1, and then I'm going to do the rest. So you got to solve it and you got to graph it. Okay, remember, if it's or, and I know this is an or because I see the word or. So it's really just 2 different problems, and then you just put the word or in between your answers. So I'm going to solve this first one here. They're kind of close together, but I know that I need to distribute first. And if it helps you, like, draw a line in between. Maybe do that here. I don't know, there's not much space here, so it kind of gets a little tricky. For my first one, I'm going to combine the x's, so I'm going to subtract over 4x. And that's going to give me negative 4. Keep the negative there. A lot of you are forgetting that. And that's 1x plus 2. Then I'm going to subtract 2. And I've got x. I don't need to flip the sign. X is less than 6 or negative 6 is greater than x. Either way. Now I come over here and I'm going to solve this inequality. So to do that, I'm going to subtract 9. And then I've got negative 9 is greater than negative 3x. Keep your signs attached. And then I divide by negative 3 on both sides, so I have to flip the sign. So that would be positive 3 is less than x. Okay, so I'm going to bring that down. And then I'm just going to put the word or in between. So let's see, any number that's smaller than negative 6 or bigger than 3. And realize, you guys, if you want to flip these around, because I know a lot of you like reading it that way, do that. So the mouth opens towards negative 6, mouth opens towards x. This is the same thing. So whichever way is easier for you to read, write it that way. When I graph it, smaller numbers go on the left, bigger on the right. So let's see. I need numbers that are smaller than negative 6, open circles for both of these here, and bigger than 3. So shade to the left, shade to the right. Okay. Now if I look at number 3, realize that in the future, like on the exam, and compound inequalities and or compound inequalities are going to be all mixed together when you're solving. So you need to recognize the difference. I know that this is an and inequality. For one, I know it's an and inequality because I do not see the word or. For it to be an or inequality, you have to have or. I know that this can't be that, and I see that it's like that between notation, so I know that this is an and. Okay, so just recognize that. They're going to be mixed together. I remember last time from these that I have to get x alone in the middle. So that's why I drew my like 2 lines there. And whatever I do in the middle, I have to do that on the left and the right. Okay, and then I'm just going to divide by 2 in all 3 places. I don't need to flip the sign. So that's my answer. X is between, so it's bigger than -4, and it's less than or equal to 16. So if I want to represent those solutions on the number line, I do not include -4, but I do include 16. And it's just all the numbers in between, bigger than -4 and smaller than 16. Now, if you guys haven't noticed a pattern, all of the or compound inequalities, the 2 numbers, like the shading, goes away from each other. And for the ands, it shades between. So, I mean, yeah, if you want to remember that, that is going to be the case for all of the compound inequalities that we do in this class. But I will tell you that it can be more complicated. It can be different than that. Like in Algebra 2, when you do compound inequalities, that's not always the case. We just kind of only do the basic ones. And, ooh, that was my phone alarm, so sorry. But realize that we only do the basic ones in this class. So the basic ones, that is the way the shading always ends up. But just know in your mind, like way back in the back of your mind, that that's not always the case in more complicated examples. Okay, I've got one more. It's an or. Again, there's not much space here, so I'm going to just draw a little line. I got to basically solve 2 different problems. So the first one, I'm going to distribute first. And yes, I have to distribute a fraction, which is not ideal, but I know that I can just do 2/3 times 3/1. So that's 6/3, which is just 2x. And then I got to do 2/3 times 12/1, which would be 24/3. And 24 divided by 3, you guys, is just 8. So that actually was not that bad. Don't make the fraction be something that it's not. That's not terrible. Then I'm going to subtract 8. And then I'm going to divide by 2. So we kind of get weirded out when it's 0, but the first part of my compound inequality solution is x is less than or equal to 0. Then I'm going to come over here and solve this. I saw some people get a little bit weird with something like this on the quiz. Do not do the 2/3 first. You got to subtract 12 first. Move what's not connected to x. Okay, now I like to move the x on top, so this really isn't a fraction. So I would write 2x/3. And then that would help me see that I multiply by 3 next. And that would be 30. And then I would divide by 2. So x is greater than or equal to 15. Okay, so bring the second part of your answer down. Put the word or in between. So if I represented these solutions on the number line, I want numbers that are less than or equal to 0 and greater than or equal to 15. So as long as it satisfies one inequality or the other, you're good. So it's closed circles above both, because I've got the or equal to. Numbers less than 0 would go to the left. Numbers bigger than 15 would go to the right.